Good afternoon. I'm Bill Stevenson, and we're here at the HRS meetings in San Francisco, and I have the privilege of speaking with Ed Gerstenfeld from the University of California at San Francisco, whose group presented some interesting work today on the use of pulse field ablation as applied not to the atrium but to the ventricle, where we really need some new tools to address patients with ventricular arrhythmias. Ed, thanks so much for taking the time.
Thanks, Bill. Great to be here.
So tell us a little bit about what did you do with pulse field ablation in the ventricle?
Yeah, thanks, Bill. So, as you know, pulse field ablation is being used commonly in the atrium, and as we know, in the ventricle, I would say our outcomes for VT ablation sometimes are suboptimal. And although that may be related in part to the complex substrate, some of it may be lack of RF penetration of the scar. So we were interested in how PFA created lesions in the ventricle, and in particular, how it would create lesions in myocardial scar.
And how did you approach this? I mean, this is a tough thing to study.
Yeah, so we used catheters that were actually designed for the atrium. We used our swine model we have a lot of experience with. So in 8 animals, we created an LAD infarct with a balloon, 120-minute balloon occlusion of the LAD, and then survived the animals for 4 to 6 weeks. In 2 animals, they were healthy controls. And then we brought the animals back to the lab. We did a high-resolution pentarray electron atomic map. And then we delivered both PFA and RFA to the heterogeneous areas of scar as well as healthy tissue. Now, I'd say importantly for PFA, one lesion, the advantage is these short duration, high voltage pulses, so it's much faster than RF. Also potentially less damage to veins and arteries and collateral structures, but has the potential also to be reversible. So for each lesion, we gave 4 applications at each site, and the PFA we use is 2,000 volts microsecond duration, but each pulse lasted 2.5 seconds. So the whole PFA ablation was less than a minute.
And how did those lesions compare to what you saw with RF?
Yeah, so we compared 2 PFA catheters, a mini basket catheter and a more standard focal catheter. Both of those catheters had lesion depths on average about 5.5 to 6 millimeters, kind of similar, and actually it's quite similar to what we saw in healthy tissue with RF, again about 6 plus or minus 1.5 millimeters. What was interesting is what we saw in scar. There was not much difference between the 2 PFA catheters, but with RF in scar, the lesions were clearly less deep, about 3.3 to 0.5 to 3.8 millimeters, whereas with PFA it was essentially the same as in healthy tissue, about 6 millimeter depth. So it seemed like we were able to, and this is measured pretty conservatively, so just perpendicular from the endocardium to the deepest epicardial extent. But we could see PFA lesions epicardial to the scar, so it was able to penetrate through the scar, and also some islands of tissue even 10 millimeters away longitudinally that were ablated by PFA. So it seemed to have a similar size lesion to lesions in healthy tissue.
Now, you mentioned that you were using catheters that are really more designed for the atrium. Do you think, is industry going to be interested in supporting this to get us better tools for the ventricle?
Yeah, obviously everyone is motivated to treat AFib because it's a huge market, as you know. We've been struggling to get companies to focus on VT. I hope they will, because I think tools like this could make it a lot more available. As you know now, it takes specialized techniques. The population is small, but with more ICD implants, it really could be helpful. So I hope so. Again, I think there is a limit to the amplitude you can use before you can get some shunting across electrodes, but unipolar perhaps, different pulse durations. Again, I think most of the companies are focused on AFib, but once that is addressed, I'm hopeful that we can get the companies to focus more on optimizing these catheters for VT and maybe doing even better.
Yeah, wonderful. RF has been so safe. It's just not been big enough lesions for some people. What did the endocardial surface look like of the PFA? Did you see any evidence of thrombus formation?
Yeah, so good questions, and we did not see thrombus. We also looked in the healthy areas, both PFA and RFA, histologically at the nerves, arteries, venules, and clearly they were all injured in RF, but in the PFA we didn't see any injury to the small surrounding arteries and veins or nerves. So as you know, that's often a challenge also, maybe more in the epicardium, but getting near the phrenic nerve, arterial damage. So as it is in the atrium, where we worry less about the phrenic nerve and the esophagus, it may also be safer where you have less endothelial disruption, less thrombus, and less injury to the small arterioles and veins.
This has really been great, very interesting work. I look forward to hearing more. Thank you so much for taking the time to share this with us.
Thanks, Bill. And thanks to Sung-Il Im, who is our fellow in electrophysiology from Korea, who was the first author and really did a lot of the work. So thanks so much, and great to be in JACC.